a new source file. The name of this source file is going to just be gcharacter. So we'll have gcharacter.cpp and click on finish. And so this is where we'll do our actual implementation. So what we'll need to do is do a pound include and include our gcharacter and .h file. And the next thing that we'll do is just do our using namespace standard semicolon. And now we're ready to start writing our actual definitions. So the first definition we'll write is just for the constructor. So maybe I'll put a comment here that this is our constructor. So we'll specify the name of the class, which is gcharacter, and then : scope operator, and then we can specify our constructor, which just simply takes a string for the name and an int for the capacity, and I'll just use n and cap. We could use an initializer list here, but I'm going to just put everything inside of the body. So we'll have an assignment here for n to name. We'll assign cap to capacity. So we're just initializing our instance variables here with those things that have been passed in. Used will be initialized to 0. And then we'll also need to create a new string array for our tool holder. So we'll have tool holder, which is a string pointer, and assign that to a new string array. And the size of that will be based off of the capacity. So that's pretty much it for the constructor, not too bad. And now we'll create the copy constructor. So here we go with the copy constructor. And the copy constructor, somewhat similar. We still have, we have gcharacter here, : This time we'll specify the copy constructor. So this time we're passing in a const. It's a constant reference to a gcharacter object. And we'll name it source, just like we did in the prototype. The first thing that we'll do inside of the copy constructor is simply do a cout operation to indicate that, hey, we've actually are invoking the copy constructor, so we can see what happens or when this is actually being invoked. So we can just say copy constructor called, and we'll just do an indel here. And now we actually get into the business of copying or assigning the stuff from this existing gcharacter object that we passed in by constant reference, and we're wanting to assign it to the gcharacter object that we're now creating. So the gcharacter object that we're now creating is the actual object that invoked the copy constructor. So whenever we specify name assignment source.name, what this is saying is take the name associated with this particular gcharacter object here and assign it to the one that we're now creating, or the one that we're now initializing. So we'll do the same thing for capacity. And we'll also do the same thing here for used. So that will come over as well. And then we'll take tool holder. Now, with tool holder, we don't want to reference the same exact string array for the source gcharacter object. What we want to do now is actually create a new string array so that each gcharacter object can be referencing its own string array. We want to do a deep copy as opposed to a shallow copy. So in order to do a deep copy, we need to actually create a brand new string array. But the capacity will be based off of the capacity from the source. All right. And so the next thing that we'll do is we'll make use of a function from the standard template library. It's a copy function, and it takes 3 parameters. The very first parameter specifies a pointer, basically, that will point to the location of where we want to start the copy from. The second parameter specifies the point where we want to copy up to, and then the third parameter specifies where we want to copy it to. So we'll specify tool holder, and that there is just simply a pointer. So the name of our array tool holder will get us to the very first element of the tool holder array, and then we can say source dot tool holder, and then do some pointer arithmetic where we add on used. So that specifies how many elements we need to shift down. And then we want to copy that to tool holder. And this tool holder here is associated with the object that's just now been constructed. Okay, there's another way that we could do that. If you feel more comfortable, you could have made use of a for loop. So we could have said for int I, assignment statement 0, as long as I is less than used, I++. And inside the for loop, the only thing that we would need to do is just copy over each element into the new array associated with the new object. So we'll do tool holder here and specify I. So that's hopefully not too bad. So that's our copy constructor. Again, you could make use of the keyword this, but it's implied. So you could have, this dot name, this dot capacity. So all that could exist there. Notice how Eclipse is really nice in the sense whenever we say this dot, it recognizes that this is a pointer and it needs to do a dereferencing, so it changes it to the correct operator there to actually dereference that pointer to the particular object that we're referring to. And so you could say the same thing over here. You could say this dot tool holder. Okay. So we always have to have some particular G character object performing any of these operations that we have associated with this class. And this just simply refers to that particular object. All right, so the next thing we'll do is the overloaded assignment. So we do overloaded assignment operator. So this is a case where we're going to return a G character object, and it's going to be returned by reference. And we'll specify the name of the class, scope operator, and we want to specify that we're overloading the assignment operator, and we pass in by constant reference a reference to a G character object. So that's being passed in by reference. We'll call that one source as well. So inside of the body for the overloaded assignment operator, we'll do a print statement once again. So we'll do a cout, and we'll just simply say overloaded assignment called, just to indicate whenever we call this, and do an endl. Because I think people, whenever they're first introduced to these concepts of the rule of three, they sometimes get confused in terms of when the copy constructor is invoked and when the overloaded assignment is invoked. Turns out that for the overloaded assignment operator to be invoked, we already have to have a particular G character object or whatever the object is already in existence before we do the assignment. In the case of the copy constructor being invoked, it's a case where we didn't already have a particular object, in this case a G character object already in existence being invoked. All right, so the first thing that we'll do inside of the overloaded assignment operator is check for self-assignment. So let me go ahead and just write the comment here. Check for self-assignment. So this is a case where we may have, so we have GC1. So we have some particular game character called GC1. And what if we did self-assignment where we said GC1 is assigned to GC1? That should be allowed syntactically, but we don't want to do any more work than we have to do. Since we're referring to the same exact object, then what we can do is just write an if statement here and test to see if this is equal to ampersand source. So we're simply seeing if the thing that's on the right-hand side of the assignment statement is equal to what's on the left-hand side of the assignment statement. So that's what's going on there. And then if that's the case, we'll just simply return the G character object. And notice that we do have to do a dereference there because this is a pointer and we're actually wanting to return the G character object itself. Well, it's going to be returned by reference because we've got the ampersand specified here, but we have to actually return, at this point, specify that it is a G character object. We're not trying to return the pointer itself. Okay, so for the next piece, it's going to be very similar to what we did in the copy constructor. So I'm going to go ahead and copy these lines of code here, 26 through 31 in my case, and paste them down below. We can get rid of one of the lines of code. Turns out that we do not need to have the line of code where we're actually creating a new string array, because we would already have a string array associated with our GCharacter object. We're not creating a GCharacter object for the very first time. We're just trying to copy the contents of one GCharacter object into another GCharacter object. So I'm going to get rid of that line of code, but the rest of it pretty much comes down as is from what we had above. Let me make sure, I forgot to do this. I'll comment out these lines of code here for our for loop, since that's serving the same exact purpose. I forgot to do that previously, but those lines of code should be commented out. So back here in the overloaded assignment operator, we're almost finished. The only thing that we have left to do is to do a return statement where we actually return our GCharacter object in this particular case. And that is basically all that we need to do in the overloaded assignment. So fundamentally, we're just taking one particular GCharacter object and copying it over to another GCharacter object and testing for self-assignment. So it's very similar to what we had in the copy constructor. All right, so now we're ready to write the destructor. So let's go ahead and write the destructor. And so the destructor here is the one that had the tilde. So it doesn't take any arguments. And in terms of the body for this particular function, it's pretty simple. I think we'll do a cout operation just to say that we're invoking the destructor. So we'll just say destructor. Actually, let's be a little bit more sophisticated in terms of what we do with the destructor. We'll say destructor called for, and then we'll specify the name associated with the particular object. And then we'll say, continuing on that particular string, we'll say that it's at this memory location. And the way we can go about getting the memory location is just by printing out the pointer this. So this is just holding some address value indicating where that particular GCharacter object is in memory. The last thing that we need to do is a delete operation. Let me make sure I change this. For whatever reason, that's not changing. So that should be like so. And then we'll do a delete operation. This time we're deleting an array, and we're deleting the tool holder, or what tool holder points to, which is a string array. So that's the only thing we have to worry about. So the destructor is only handling the dynamic memory that we allocated. Any other memory that was allocated, we don't have to worry about. It's just the dynamic memory that we have to be concerned with. All right, so we've got the destructor. The next thing we'll code up is our insert. So I'll have a little comment here saying that this is for inserting a new tool into our tool holder, being verbose there. So this is a void returning function. Let me scroll down a bit. So we got void GCharacter, and this is our insert. So this is a constant reference to our string. And we'll use the word tool name for the identifier. And in here, we'll just say if the use capacity, or excuse me, if used is equal to capacity, we know that we cannot put any more tools in there. So in this case, we'll just do a cout operation and just indicate to the user tool holder is full, cannot add any additional tools. Okay. Maybe we'll come back later and change this up a bit so that we can have a dynamic array that can expand if we need to add in additional tools. So if that's not the case, we'll have just an else statement here. And in the else statement, this is where we'll actually add in the tool. So we'll just say tool holder, specify the index by using the used variable, and then using whatever the tool name is. And the other thing we have to make sure of is to increment used. Otherwise, used won't actually hold the proper index value. Got to make sure that that's being incremented every single time we do an insert operation. All right, so let's do one more. We still need to do our overloaded insertion operator. So we'll do that. So this is our overloaded insertion. Very similar stuff to what we've seen before. So we pass in our OStream object by reference, since we will not be modifying the OStream object itself. And we'll also pass in our GCharacter object by reference, our constant reference to be more specific. We'll just call it GC. And in here, we'll do a string that just says game character, whatever game character we have. So we can get the name of our game character, gc.name. And I'm going to come to the next line. And let's see, we'll do a new line character and say has the following tools. And here we'll just say std : indel, and then we'll also concatenate on a pipe symbol, or we'll output a pipe. And what we'll do is actually iterate over our tool array and just simply print out the tools that we have. So let's see. So we've got that, and now we'll have our for loop here. So we'll say for int I 0, as long as I is less than gc.use. And then in here, we'll output some more stuff. So we'll say gc.toolholder and specify our index using I. And then we'll concatenate on a pipe symbol, just so that we have a pipe separating each one of our tools. And we'll do a semicolon. And then outside the for loop, we'll just simply return our OStream object there specified by OS. And we'll also do, an indel, just so we have a new line character there. And that is pretty much it for our gcharacter.cpp file. So we've done the implementation for everything that we set out to do. So we have our copy constructor, we have our overloaded assignment operator, we have our destructor, we have that other member function that we wrote for doing an insert of a tool into our tool array. And now we also have an overloaded insertion operator. So that means that anytime we do a cout insertion operator and reference or have on the right-hand side a gCharacter object, we'll be able to make use of this. It'll automatically be invoked.